Hi, we're the Ocean Going Robots ECE Capstone team. Our team consists of Malachi Fisher, Grayson Lewis, Miles Drake, and Samuel Barton. Our project is to develop a system to measure swell amplitude, direction, and period to be fitted to a Slocum G3 glider as it floats on the surface of the ocean while consuming a minimal amount of power.
Our goals from the previous weeks were to continue building up the PCB and testing the individual blocks as they were assembled, to begin compiling our individual firmware contributions to create the final main firmware for the system, and to continue working on project documentation, including the draft for our poster.
So we successfully built the system PCB. We also tested all the board's main functionality. There's two UART ports on the system PCB, which both of those we tested, and it can transmit and receive data very well. We can store and read data on the SD card that's off of the system PCB and on its own piece of hardware. The Xsense accelerometer can measure data accurately, and that data then gets transferred to the microcontroller without any issues. The buck and regulator can convert a 17-volt input voltage down to 3.3 volts with a very high efficiency. And the RS-232 converter can convert our low-level 3.3 voltage signals up to the RS-232 suitable ones, and vice versa without any issues.
Yeah, so we got together and met with the CS side of our team this week to go over the work that they've done. We looked at the data analysis functions and code that they had implemented. We foresaw some potential issues with integrating what they'd worked on with the STM32 board, so we discussed what changes need to be made so that we could properly combine our code to make a fully working system. As it says here, their code used quite a bit more memory than our microcontroller could handle. So we're working on ways to cut down that memory usage to create a more memory efficient process.
So our next steps include building some UART firmware, which will handle all the communication between the science computer, the system PCB, and the PC application that's external to the system. Right now, we're primarily focusing on between the science computer and the system PCB, in which we'll be checking for the initial timestamp from the science computer. That'll be the one telling our system PCB to start taking measurements, and then we reply back with the same timestamp that the science computer sent to us. We then check for the signal to then finish taking measurements and start calculating our 13 parameters, and then we send all 13 parameters back and we lose our power. That should be pretty much all that's handled through the science computer and system PCB UART.
Yeah, so I've been working on just polishing up the SD firmware. So I have it parameterized. I've got it in different functions now so that we can fully communicate with the micro SD card from the STM32. We've got some functions that handle the string conversions and then format the file on the SD card correctly to what our project partners desire. I also have the inverse of that created so it can take the formatted CSV file and read the data back out of it and use that for the inputs to our various functions in our systems. And a big part of it, it needs to be efficient in reading and writing, not use too much power, and also importantly, not use too much time when doing these reads and writes.
I'm going to be working on the Xsense firmware. So this is the firmware that interacts between the microcontroller and the accelerometer. I have some basic functionality working, and we're able to read data out of the sensor and do some math with it. and that's all well and good, but I'm going to be implementing some more robust packet parsing so that we can deal with receiving multiple packets at a time. And I'm going to also create some easy functions for initializing and configuring the sensor. And then I'm going to wrap all that functionality into an easy to use library that functions that our main firmware can call.
And then the main firmware will be bringing all of the previous firmwares that we mentioned together and running them at the proper time so that this can all function within the glider. I have the pseudocode written up for this and some structure, but I'm still waiting for those peripheral functions to start coding for real. And I'm still sort of deciding what time intervals we want to use for grabbing data from the XSense and how often to send data to the SD card. And these things will kind of depend on how long it takes to do each of those things.
Our goals for the next week, really the next couple of days, is to get a working finalized firmware, get through system verification, and then finalize our project documentation. And